you expect us to drink that?
Of course I do. It's delicious and super healthy for you.
How is it healthy?
In addition to containing lots of fruits and vegetables, this smoothie is super high in calcium.
What's that?
Only one of the most essential and abundant minerals in the human body. Have you guys never heard of calcium?
No.
Do you want to learn about it?
Sure, sounds like fun.
This is the periodic table. Its 118 elements make up the world as we know it today. Now take a look at the element calcium, our element of focus today. Notice how it has the number 20 in its top left-hand corner? That's calcium's atomic number.
Why does calcium have the atomic number 20?
Take a look at this model of calcium. It has 20 negatively charged electrons, represented by the white calcium pills, and 20 positively charged protons, represented by the red pom-poms. This is why it has the atomic number 20. In all elements, the number of neutrons the element has will always equal the element's atomic number. And if the element is neutral, the element's number of electrons will also always equal the element's atomic number. Calcium's atomic number makes it so that it's positioned in front of scandium, represented by the letters Sc, and behind the element potassium, represented by the letter K. However, calcium's energy level is the reason it's in row 3 and number of valence electrons that place it in column 2.
What are those?
An element's energy level is how many electron rings, or shells, the element has. Calcium needs 1, 2, 3, 4 electron shells to hold all of its electrons. That's why it's in row 4 of the periodic table. Valence electrons are the number of electrons that an element has in its outer shell. Calcium has 1, 2 valence electrons. With a few exceptions, an element's number of valence electrons correlates with its row number. Because of calcium's atomic number, energy level, and number of valence electrons, it is positioned where it is on the periodic table. We know a couple of things about calcium just from its location on the periodic table. First of all, because it's in the second column, we know that calcium is an alkaline earth metal. These metals are a very reactive group of elements, second only to the alkali metals. Alkaline earth metals also have relatively low densities, melting points, and boiling points. Two other things that you can tell from calcium's location on the periodic table are that A, it's a metal, and B, it's a solid at room temperature.
How do you know that?
Well, most elements to the left of the green line, running from boron to acetane, are metals. Calcium is on the far left side of the periodic table and is in the alkaline earth metal family, so we know it's a metal. Aside from mercury, highlighted in green, all metals are solids at room temperature. There's one last thing I haven't explained about my model. See those black dots in the center? They represent neutrons. Neutrons are the particles in an element's nucleus that have no charge. If you subtract the number of protons an element has from its mass number or isotope, you get its number of neutrons. Calcium has a variety of different isotopes, such as calcium-40 and calcium-41. I chose to represent calcium-40, and because calcium has the atomic number of 20, it has 20 neutrons. An element's mass number or isotope is not to be confused with its atomic mass, or average of all its isotopes. Calcium has more than one isotope, so the number for its atomic mass and the number for the isotope calcium-40 don't match.
That's really cool.
Calcium is an awesome element, and that's not just because of its location on the periodic table. Calcium is super useful. Did you know that it's used in the construction industry?
What? I thought it was only important to the human body.
Not at all. The compound calcium carbonate, limestone, calcium is used directly for building. The Rockefeller Center, the Empire State Building, the Pentagon, and the Lincoln Memorial are all made of limestone. Limestone can also be heated to become quicklime, calcium oxide, which can be mixed with water to become slaked lime. This compound can be used to make cement, treat water and soil, remove impurities from steel, and much more. Also, have you ever heard of plaster of Paris?
I think so.
Plaster of Paris is actually gypsum, or calcium sulfate. This is another compound made from calcium. Another important use of calcium is in spotlights. Have you ever heard the term "in the limelight"?
Of course, I am an up-and-coming actress after all.
In the early 19th century, it was discovered that if a block of calcium oxide, known as lime, was heated until glowing in jets of burning oxygen and hydrogen, it could be focused through some sort of funnel to create a spotlight. Until replaced by electric lighting, limelights were used in theaters all around the world. Calcium is also important in the natural world. Calcium is the 5th most abundant element and the 3rd most abundant metal in Earth's crust.
So we're standing on calcium right now? Well, technically sitting. You get what I mean.
Yep. Calcium is also present in just about every living thing, plants included. As I said before, calcium is really important in the human body. Almost all of the body cells use calcium for important functions, such as building strong bones and teeth, making blood clot, releasing chemicals, keeping a normal heartbeat, and making muscles contract and relax. The human body contains almost 1 kilogram of calcium.
Wow, calcium really is important. I heard you say something about bonding. What's that?
Well, there are a couple different types of bonding. The first is ionic. Over here, I have drawn a model of the element calcium. I've only drawn in the 2 valence electrons, as those are only essential in the bonding process. Over here, I have drawn 2 chlorine atoms. Unlike calcium, they have 7 valence electrons. Now, when elements bond, they want a full outer or valence shell. So calcium will lose both of its electrons to chlorine. Now all of the elements have a full valence shell. Because calcium lost 2 negatively charged electrons, it has a charge of positive 2. And because both of the chlorine atoms gained 2 negatively charged electrons, they have a charge of negative 1. These negatively charged atoms are called ions. Now think of what happens when 2 oppositely charged magnets come close together. That same thing happens to ions with opposite charges. As a result, the 2 chlorine atoms and the calcium atoms bond together. The charges equal each other out, so the overall charge is 0. The compound is written like this. And has the name calcium chloride.
Wait, why chloride? Why wouldn't it be chlorine? Why doesn't calcium come first? I know calcium is one of the most amazing elements out there, but that doesn't explain why it comes first.
Well, when writing element names, the element that has a positive charge, usually a metal, comes first, and the ending of the second word is changed to IDE. So instead of being chlorine, chlorine is chloride.
Weird.
I think I told you everything that I know about calcium.
It's a fascinating element.
Yeah, thanks for sharing.
You're welcome. Hey, you guys want to take my dog on a hike?
No. Sure.
Hi, Katrina. Yeah, I know it's late, but I forgot to tell you about something important today. I'll just tell my sister tomorrow morning. So, did I tell you about the sea of electrons? Okay, so you know how metals form crystals? Okay, good. Well, in those crystals, the metal's valence electrons move around freely, so the metal atoms become positively charged. I don't care if you're tired, this is important information! Anyway, so the metal's atoms become attracted to random valence electrons. Because of this, metals can bond with metals of their same kind to form metallic bonds. This property of metals explains a lot about them. Take electricity, for instance. Metals can conduct electricity so well because their valence electrons can move around. See, I told you it was important. See you tomorrow. Bye.
Really bad flavor. Hi, and welcome to Skittle Chat. Today we'll talk about the many interesting flavors of Skittles.
My personal favorite is orange. What do you think about that?
Well, there's orange, but first we gotta go in the stinking frickin' order of the rainbow. There's red.
It's called strawberry.
Oh, right. It's called strawberry. And there are so many different types of strawberries. There are little ones, and big ones, and green ones. And
Where do you find a green strawberry? That's not right.
I don't know. Guatemala. I don't know. Then you got the orange. After the orange, you just throw those away. Then you got the lemon. Lemons are very sour, but these ones are sweet. Oh, I missed.
Who's gonna drink that?
Pretty soon we're gonna have lemonade. You wait a few minutes and then it'll turn into lemonade. And then we got our green apple, which used to be lime. Lime was so much better, but now it's green apple.
Yeah, I totally
We got
agree.
green apple lemonade. And last but not least, we have the grape,
Which nobody likes.
which nobody likes unless you're in Napa, in Wine County.
Actually, I like
Country or county? Wine Country?